In this tutorial, we will continue talking about our new interesting light current system, the CCTV system. So fasten your belt and let's get started. The aim of this tutorial is to continue discussing the different types of the CCTV components. So we need to know what are the different components of the CCTV system and what are the different specifications of each of them. So let's go ahead. If you remember, in the previous tutorial we talked about the DVR and its different specifications, but now for the DVR device it has some more specs that we can select it according to. And the next specification that we can select the DVR according to is the video resolution. And this video resolution is a reference of the video quality, as it's the precision or the ability to show the small details of the video in a clear way. And this video resolution is described by the number of units or the number of pixels that each frame is having, as the more number of frames in each video, the higher resolution the video is, and the higher quality the video is also. And this resolution is specified by the number of horizontal pixels in the frame times the number of vertical pixels in the frame. And some examples of the different resolutions are 384 times 288, also 704 times 288, and also 2048 times 1536. So when we say 2048 times 1536 resolution, for example, this means that each frame in the recorded video is having 2048 pixels horizontally and it has 1536 pixels vertically. Hence, when we buy a DVR, we take into account its video resolution as a part of the system quality. But take into account that when the video resolution increases, the size of the video will increase, and as a result, we will need a larger storage hard disk to store the recorded videos. So we need to make a balance between the video quality and its available storage, not to have a bad resolution of the recorded video, and not to have a very large size of the video that the storage element cannot have enough space to save it. Alright. Now we need to know what are the different available parts of the DVR device that represent its interface. So what is the interface of the DVR which it can be connected to? Here we find the first type of ports of the DVR to be the camera's different channels, which are those outlets here, and each of them is connected to one cable which will be connected to one camera. Also, the second type of interface is the interface with the displaying monitor, which is this socket here, which is called the PNC outlet. So this PNC outlet will be connected to the data cable, which will be connected to the displaying monitor to display the recorded video. Also, the next type of outlets we have is the HDMI outlet. And this HDMI outlet will be connected to the HDMI cable that is connected to a monitor also to display the recorded video. Also, we have another method for connecting the DVR with the displaying monitor, which is the Vega outlet. So this type of outlets is called the Vega outlet, which will be connected to the Vega cable and it will be connected to the monitor on the other side to display the recorded videos by the camera. So both of those two outlets are available for connecting the DVR with the displaying monitor, the Vega outlet, and the HDMI outlet. Then the next outlet we have is the input audio outlet. This is because the DVR system is not recording just visual signal, or it's not recording just the videos, but it may record also the audio as an input from a microphone or from a camera, as some types of cameras are having a built-in microphone for recording the audio as well as recording the video. So this input audio outlet here is used in the DVR device to record the audio signal. And by the same way we have the audio output outlet, and this audio output outlet is used to display the audio signal on a speaker, for example. So a speaker may be connected to the DVR to display the recorded input audio. So we can consider the DVR device to be an audio-video displaying device where it can display a video with its recorded audio. Also, the next important outlet that may exist in some DVR devices is the RJ45 data outlet, and this data outlet is used in some DVR devices to connect the DVR with a router which can display the video on a LAN network, or it can send the video to another remote network through the internet or through the WAN network. And by the same way, we can monitor the recorded video in one building. For example, we can monitor it remotely from another building or from even any country, and this is using the RJ45 data outlet by connecting it to the router and connecting it to the DVR from the second side. Also, the second outlet we have is the power supply outlet, and it's used to supply the DVR with the required electrical power, so the DVR is supplied by 12 volts DC volt. Now we need to know how can we size the required storage space of the DVR. As we said, the DVR needs a storage space to save the recorded videos in. And here we find there are some standard storage sizes that we can find in the market to buy the DVR with. And those storage capacities are 0.5 terabytes, 1 terabyte, 2 terabytes, and for the larger capacity applications, when we need a more larger storing size, we can use the 4 terabytes DVR or the 8 terabytes DVR as a hard disk capacity. But now the question in your mind may be that, how can we select the suitable capacity of the DVR from those different capacities, or which capacity will be sufficient in our project? Here we say that the DVR storage capacity in gigabyte is calculated from this equation, where the required storage capacity of the hard disk in gigabytes equals the frame size times the frame per second times the number of cameras that this DVR will be connected to times the total number of days times the number of hours per day times 3600 times 10 to the power minus 6. So this is the storage capacity equation of the DVR in gigabytes. And we can analyze it now to understand each parameter of it. Here the storage is the storage in gigabyte, or it's the total required storage of the hard disk in gigabyte. Then the frame size is the size of each image in kilobyte that the video consists of, and it may be 15 kilobyte for the lower resolution cameras. So we set this value in kilobyte. Also, the frame per second is the standard frame per second that the DVR records the video based on. As we learned before, it may be 25 frames per second according to the European standard, or it may be 30 according to the American standard. Then for N, it's the number of cameras that will send the videos to this DVR. Then for the number of days, it's the total number of days in each complete cycle that we need the DVR to record the video on. And the meaning of this cycle is that we need a period or a cycle that the DVR will continue recording the videos on before the hard disk is completely full. And we specify the cycle according to the owner needs or budget. For example, we may need the DVR to continue recording videos before being completely full for just 1 week, and in this case the required hard storage will be low, as in this case the cycle will be just 7 days. But suppose we need the hard disk to continue recording for 1 month, for example, without being completely full. At this case, we need a larger storage size of the hard disk, and at the same time its price will be bigger. And after completing this cycle, the hard disk may overwrite its storage size, which means it may erase the older videos that are recorded firstly to free new space in the disk to have an additional size for recording more videos in the new cycle. So the days here is the total number of days that the hard disk will continue recording new cycle on which may be 30 days for example, or 14 days according to the designer needs. Also, the number of hours here is the total number of hours that the DVR will record the videos at which, and in many cases we set this number of hours to be 24 hours as we need to monitor the building all of the day for the security purposes. And finally, 3600 is a constant that is used to convert from hours to second, and 10 of the power minus 3 is a constant also to convert from kilobyte to gigabyte. So that's the way we can design the DVR storage size. More than great. So that's about this tutorial, and on the next one we will continue talking about the analog CCTV system. Thank you for watching and see you next tutorials.